Hello and welcome to another CAD Dimensions Lunch and Learn. Today our topic is SOLIDWORKS Utilities and the tools within utilities. My name's Kevin Holbrook. I'm one of our application staff here at CAD Dimensions, and if you've never attended a Lunch and Learn, our goal for these sessions is to basically take you through an area of the software that maybe is not touched very often and give you a glimpse into its uses and how it might fit into your workflow of designing day-to-day with SOLIDWORKS. Today's agenda, pretty simple. What package is utilities included in? We're going to cover that right up front, and then we're going to go through each of the tools and then close with some Q&A. If at any point during the presentation you do have any questions, you can post those in the GoToWebinar question section. Please don't post them in the chat. At the end of today's presentation, I will go back and take some time to answer any of those questions to make sure everything is clear that was presented today. So, what package is SOLIDWORKS Utilities included in? Well, the answer is different depending on which release you have. I'm using SOLIDWORKS 2016, and in this current release, SOLIDWORKS Utilities is now included in the standard package. That's kind of what prompted the review of this particular product. We want to make sure everyone is aware what they have, because everybody has this tool now, along with FeatureWorks coming down to the standard package. So we wanted to cover this because it's no longer an add-in that you would have to purchase. It is included. So what is utilities? If we could give one simple sentence that describes utilities and all of the different tools built into it, it's to utilize and get an understanding of the geometry of a model. Things like comparing, selecting, and analyzing the geometry of a solid model. So it's a bunch of tools. Today, excuse me, today we're going to cover 7 or 8 of them in the next half hour. And they're all about examining the geometry. They don't help you create more geometry or anything like that, but it helps you to examine what you have. So let's start right out with the very first one. The one probably that has the most awareness through the customer base. It's a utility for comparing. Now, there were 5 different tools built into this for compare. One of them spun off and was included in the base package before utilities came down. It's for comparing drawings, and we're going to keep that out of the conversation today. You can discover that under the tools menu. You'll find a compare, draw, compare. But we're going to cover the others that are listed there. Compare allows me to take 2 documents or 2 separate configurations and either compare their properties, compare their features, compare their geometry. They may be just imported files, or if they're an assembly or a drawing, their bill of materials. Let's take a look at how this works. So the compare tool can be found under the tools menu, compare. There are the 3 separate options in here, and there, as I mentioned, is the draw compare tool. Let's just select any of these at this point. The reason why I say any, because they all use the same interface. They use the task pane. It creates a new tab, and all of the different things you can compare are all in the same interface. So we're going to start out with comparing document properties, but work our way kind of through this. Now, it does require us to present it with 2 separate files. Now, there is some integration, at least for document properties, if you have our PDM systems. But what we need to do is select the files that we want to compare. Now, I happen to have both files open. If you don't, just hit the browse buttons at the end of each of these. We tell the software what we want to compare, and then we can hit this run comparison option. Now with properties, it's comparing some of the basics that Windows provides, like size and when it was last saved, but it also does tell you if there's any unique custom properties. You can see the original pump housing has 2 custom properties that are unique, and it actually lists out that description and unit of measure are unique to this particular file. So we have a good little look into custom properties. However, it does not say this is the description in one, this is the description in the other. Under part properties, it does give you kind of a face count, how much graphics card hit it is, mass, volume, maybe some center of mass coordinates. So some basic information. Now this interface here does allow you to save out a report. You can browse to where you want that report to reside. In mine, I'm just going to bring this right to my desktop and give this a name. I'll just call this compare. Notice there is option to add the report to the design binder. If you've never seen the design binder, what it is a folder in the feature tree that you can actually add files to, and the software can physically add this report file to it. So there's one example comparing properties. Now if I hit back on the compare utility here, I can automatically go back and start comparing other things. With this example, I'll turn off document properties and tell the software I want to compare features. Now these happen to be 2 SOLIDWORKS files, and with that it can take a look at the differences between the features. It uses the feature names to understand if they are the same. So keep in mind, if the feature names do change, they will be treated as a unique feature name, regardless of whether or not the extrusion distances or end conditions are the same. So when doing a compare features, it's going to look again at the feature tree, find out which features are unique and which features are modified. So you can see here between the two that there are 0 unique features. So there's no features that are only on one versus the other, but then it tells me there are 9 features where there's a difference, a modified value. And just to give you a quick look in there, if I select the circular pattern, you can see in one there are 4, in the other there are 6, and it shows you the differences between them. Now obviously this needs to be a SOLIDWORKS file for this to happen, but feature compare is part of the compare utility. Now geometry compare is a little different. These are for parts that don't necessarily have features associated with them. So it ignores the features, it looks specifically at the geometry, and when you run a comparison, it's going to look individually at the volumes and faces of the geometry. Now, the way I like to look at this particular compare functionality is to use these 3 buttons at the top. Now, these little eyes here are just like the hide show that we have in SOLIDWORKS assemblies today. If I click on the item, it's turning on that filter. So material to remove shows me in each model what material I would have to remove to make it the same as the other model. Okay, if I turn on material to add, okay, it gives you a clear look at what the differences are between the two. And then I also have ability to turn on and off the common bond. Now, if I turn this on, keep bodies on close, it will actually create separate bodies of the differences in each file so that we can use those for future use. Okay. At the bottom is a face comparison, just going to a little bit different level, looking at each face individually instead of the thicknesses and volumes that we have. And if I turn on unique faces, I can see which faces in the software are completely unique. I can see which faces have just been modified. A simple modification, you can see this top extrusion slid along the cylindrical face. This makes the face the same because it exists in both, but it's changed because that part has slid slightly. And again, this can be saved out as a report as well. Now, the only other instance I want to bring up with this particular utility is when you have two imported files where the 00 is not necessarily in the correct location. If I just window these two files, you can see where the origin is relative to the two files I have. In this case, when we do a compare, let's say geometry in this case, because the origin is not the same, it has trouble doing a comparison. So let's select the two versions. What I'm going to have the ability to do is align the parts. Now, the global coordinate system isn't going to help me because my 00 is not really in the same spot. So I would have to come in, and I've already done this, to create my own coordinate system to compare. So I can say, okay, I'm going to use these coordinate systems, which are set the same in both, and then I get the same thing. Material to add, material to subtract. It shows you where the original part was. It's kind of ghosted out, but it does give you the same kind of results. Material to add, material to remove, and it gives you a nice look into everything. Okay, I have somebody saying that we have some audio issues. If I could just have you, let's see here. Raise your hand in the GoToWebinar window if you can hear me at this point. There's a raise your hand. Okay, so it might be just isolated. I just wanted to make sure I wasn't leaving someone behind here. So let's go ahead and continue on. So that's the compare utility. Compare is a nice one of those utilities that we can utilize. And keep in mind, you can save reports. I see that being used. Let's say a customer sends you one file that you've imported, and now they send you another one, and you don't know the difference. It's an imported file. Or if you have two files on your network and just not sure of the differences between them. The second one is a tool called Feature Paint. You know, we have parameters that we put into our extrusions, such as depth, color, texture, optical properties. Feature Paint is going to allow me to copy those parameters from one to the other. This one's very simple. Okay, this one is found under the Tools menu. You'll find it under Tools Feature Paint. This area right here is kind of where most of the utilities are. They're all built into the interface now. But Feature Paint is very simple. You can see I have a whole wizard hole that's through all in red, and I have a whole wizard hole that's not through all. It's an M6. What I can do is select in this task pane window, it says copy properties from. I pick the original counterboard, and then I can paste the properties to another by selecting the second counterboard. Now it does give you a nice little preview of what the differences are between the two, and you can even see what properties it's able to move over. You can see that the appearance properties are included. That can be turned off with this little option here. But when I say apply, it now sets that as the same color and same depth. Now I can continue to use this at this point. I can select the fillet. Okay, I can say let's paste the properties to this fillet. Notice I have the different colors, I have the different sizes, tangent propagation, keep features, rounded corners, some of the properties specific to the fillet that are there. I can go ahead and hit apply, and it will apply that same value to those as well. Okay, so Feature Paint, a little utility to start working between your features maybe a little differently. Okay, continuing on. A utility called Find Modify. Now it's important to see that there's two separate pieces here. Find the features basically that belong to a specific type or satisfy your criteria, and then once I find them, modify them. Let's take a look at how that one works. So if I go and find this particular part here, I can go to Tools, Find Modify, and you'll see Find Modify. There's multiple options below it. Find Modify Features. Now the first thing it asks for is a feature to use as a comparison to get the parameters from. I'm just going to pick the hole wizard hole here on the outside. It's a 1/4 tapped hole. Now there's different categories of things that we're looking for. Are we looking for bosses, cuts, features, pattern? Under features, there's a sub-menu for different types of features. So I want it to find hole wizard features. Now to match them, I can come under the section under match called feature parameters, or I can do this by a volume check, but just looking for something of a similar volume. If I edit feature parameters though, this gives me a section of find where I can go into all hole wizard holes and say, you know what, show me everything less than, let's say 5 millimeters. Okay, so I want all hole diameters less than 5 millimeters. Now that I have the parameters set, I just say find now, and it finds whatever hole is less than that particular value. Now let's do a different one. Let's grab a fillet and tell it we want to again look at features. Maybe is it a simple fillet, variable fillet? Let's look at the parameters here. Let's find everything less than 10 millimeters. Okay, we'll go ahead and let the software find those, and you can see at the bottom here, this takes just a second, that it found multiple. Now the second part of this tool is to modify. Maybe I want to select one of those, and if I scroll a little further down, I can go to the parameters under the modify section. And I can say, you know what, set this to 1 millimeter. Okay, now we have an option to modify all or modify selected. If I say modify selected, the software is physically going to go in and modify that particular fillet. Now it does have to do a rebuild. It's modifying it wherever it is in the tree, so it may take a moment to complete in this case because the part's got a few features, but I can go ahead and modify. Now notice it still says an 020. That's simply because when this part was originally modeled, the feature name was set. So utility called find modify. Really nice to do things and make changes in bulk. Okay, keeping going. In the same sense, for a drawing, we have a command called find replace annotation. So when we're looking at a drawing and we want to find a particular piece of text and replace it with something else, instead of searching all the spots or all the pages, we can use this utility to do that. So let's take a look at what the options are for find replace. Now I have a very simple drawing here with some notes in the corner. So if I go to tools to the same section under find modify, you'll notice because it's a drawing it doesn't have the find features or find and modify functions that we had before. In here, for some reason this one isn't using the task pane. It actually uses the property manager, but it looks exactly the same. We can tell it what we want to find. I'm looking for the word specified, and I want to replace it with replace. I'm just throwing some words in here. Now, if I hit find next, it's going to search the drawing for the term specified. Even if it's within a word, we can control if it matches the whole word, matches the case, includes hidden annotations, and which annotation types that it's actually going to search for. But once it finds the value, it doesn't automatically replace it. You can hit the replace button and do these one at a time. So as you hit find next, you can replace on through. And I'll show you if we do the replace all. Okay, says there's no more in this. I want you to also notice, if something's spelled incorrectly here, where it says unspecified and specified is spelled incorrectly, it won't recognize that. But it's a nice, easy way to go in and make fixes to text and terminology. But this works in tables, in bill of materials, and title blocks, and all those different spots that you might want to replace an annotation. Okay, so another nice tool now included in utilities. Geometry analysis. Any of you doing an analysis with simulation or just in general wanting to make sure that they've built the highest quality model because it's going to be used downstream and other applications, other CAM applications, maybe to create mold tools. If we use this tool, we can ensure that we've done the best we can do with our modeling. It's called geometry analysis. What geometry analysis is going to allow us to do is take a look at the model and find out if there's any surfaces, edges, faces that are maybe of not the best quality. And it will help us to understand what caused that. Now this is an imported file in this case. So if I want to find this tool, it's under Tools. Now this one is not in that same section. It's down near the bottom. It's called Geometry Analysis. All of these things you can look up in the help, but in general, short edges are very, very small edges. Small faces, again, very, very small faces. Sliver faces are faces with a high aspect ratio. You know, one end is almost triangular, but they're long and triangular. High aspect ratio faces could cause failure in meshing, could cause failure in export to like an IGES to another system or other neutral formats. You'll want to get those cleaned up. And then it looks for something we call knife edges and knife vertices. Again, edges that have really, really sharp connections or vertices that are at the end of the sharp. Now at the bottom, it's looking for discontinuous geometry. These are for edges and faces that are not tangent to each other. So if you're building a plastic part and you want to make sure faces are tangent, you can do that. Now by calculating this, it's going to go through and give me a nice little result for each of these. And again, we have the ability to save out the report. If I save out this report, I'll call this GA for geometry analysis, and I'll go ahead and save the report out. But if I look at these, let's just start with short edges here. If I select the first short edge, it does highlight it and tell you the length of the edge. And now you can zoom in there and see that somewhere along the way, my fillet has, or a fillet or import, has created a very, very small edge. Now, if I were to try to mesh this, this is an area I would probably have a little bit of trouble with. In the same sense as a short edge is something called a sliver face. Now, a sliver face is the face that belongs to the edge. Apologize for all the zooming here, but you can see it's a high aspect ratio face, and the software will point out whether this might create issues. And you get a nice little report of what's good, what's bad. Now, in reality, if it's imported, what you might want to do is delete face, maybe do some patching, create your own surfaces so they're single surfaces. If it's a SOLIDWORKS model, you want to look at the fillets. You want to look at the order of fillets and try to figure out why that face exists and how it got created so you can maybe clean it up a little bit, change your radiuses, and so on. So geometry analysis is important, especially if you're sharing files with other people or doing simulation. A tool called Power Select, I'm going to show this, probably the least useful of all the tools because we have some of the advanced select techniques in SOLIDWORKS. This Power Select is exactly what it says. It's going to allow me to select things quickly. So if I go under the tools, it's found just above that first section we've been working at. Very simply, you'll probably use this most often for selecting features, but I can tell it to select features. What parameters am I looking for? Am I looking for features of a certain color, a certain name, a certain type, or a certain type of feature? In this case, I have it set to cuts. Okay, I just tell the software to search, and it picks all of the cut features within the model. Now, what you should do from here is be able to select the features, maybe suppress them, change the color, do other things to it. but this really allows you to make selections in a much more rapid sense. Okay. Continuing on, there's a simplify utility. This one is probably one of the most underutilized utilities. If any of you online are creating large assemblies, one of the things that we preach all the time is to simplify your parts or assemblies so that you get the best performance at the upper level. This is a utility that you can use to help you do that. Let me show you how this one works. So if I have, and this happens to be a small assembly here, under the Tools menu, okay, Find Modify, you'll see Simplify. Okay. Essentially, it's looking for small features within parts that it makes sense to get rid of, so that when this goes into the next assembly up or multiple assemblies up, that it doesn't have the level of detail that you have here, simply because it makes it faster and easier to work with at those upper levels. So the first thing you're going to do is put in a value between 0 and 1, what we call a simplification factor. It's looking for essentially different volumes or different feature parameters, and you can look through the help and see the difference between these two. I can have it ignore features affecting assembly mates. So one thing we don't want to do is create a simplified version where the mates are all messed up. So by setting the simplification factor, I can just tell it to find features that meet that criteria. In this case, there'll be 4 or 5 features. If I look through these, there's a tooth cut and then a fillet and a couple other tooth cuts. Now, by getting rid of these, the patterns for these are also going to go. Now, I don't just want to get rid of them because I do create drawings where I show this thing detailed out. So if I scroll a little further down, I have the option here to suppress. But the one I want to point out is create derived configurations. And I know if you've ever sat into any of our large assembly presentations, we talk about creating a simplified configuration when you need to use something at the upper level. Now watch this. I can select all these, tell it to suppress all, and create derived configurations. All in one shot. It's just going to tell me here that it's going to have to change the reference configuration being used in this assembly, and it simplifies it. It removes the holes, the cutouts, simplifies the assembly. But check this out. If I look at the assembly, it actually created a configuration called simplified for these two parts. I can go back at any point in time. Let me just close the simplify tool. I can click on the part and switch back to the other configuration. So it's not like all is lost, but it's done some of that work that you would do manually automatically by using simplify. You can do this yourself manually by creating a configuration, or you can use simplify to help you to do it. But that's now included in everyone's See to SOLIDWORKS. There's a tool for checking symmetry in parts. So if you've ever grabbed a part and wanted to know if it is completely symmetrical, where I would use this most often is if I'm doing analysis and I want to see if it does have quarter symmetry or half symmetry, so I can maybe simplify the model in some way. So very simple tool to use. It's under Tools. Down near the bottom, we have Symmetry Check. We can do it with a single plane, multiple faces, or points as the axis of symmetry. Okay. In this case, I'm going to just select a plane that runs through the part in the center here, and I can tell it to check symmetry across that plane. You can see that it tells me the part is symmetric, and it tells me the symmetric faces. Now, along with just telling me the symmetric faces, it can tell me which faces are cut by that plane of symmetry and which faces are uncut by that plane of symmetry. Okay. Again, we have the ability to save the report. Okay, I can save that to my desktop again. and store that where I need it. Now there is also another tool built into this called the automatic symmetry split. So this doesn't look for a plane. What it does, it looks automatically for the axes of symmetry, and it splits the part automatically. Okay, so only thing it's asking me is select the bodies to keep. Now you can see there's three bodies. There's half symmetry and quarter symmetry. If I tell it to split the part, then instead of having to make my own cut, it will split the part for me and get it ready for analysis with quarter symmetry. And you can see the split feature at the end of the feature tree that can be suppressed to bring it all back. Okay, so a real nice and easy symmetry tool. Thickness analysis. This allows you to identify thin and thick regions, helpful for designing plastic parts where you're trying to hit a specified thickness target. Sheet metal parts, if you're importing somebody's sheet metal part, maybe from an IGES or a step, and it won't unfold, there could be an issue with the part being thick in some regions, so not uniform thickness. And you can use thickness analysis to analyze this. Thickness analysis, again, very simple to find and run. It's found under Tools, Thickness Analysis. You tell it what your target thickness happens to be. Do you want to see thin or thick regions? What is the thick region limit? Okay, let's just do 0.1. Okay, how do we treat corners? Are we worried about corners and radiuses? And we can tell it to go ahead and calculate. Now, there's different levels of quality settings for the results. It can give you a general report, which you'll see here in just a moment, where it color codes the different surfaces to let you know what is thick and what is thin. There is a target thickness color option, which is gray at this point. So anything beyond the value of the 075 that I have will be color coded in some way, and we do get a nice little chart saying the variations in those thicknesses. Now, if there's any faces that you want to look a little closer at, maybe the faces on the model here, you can make those selections right in the graphics area. Notice I do also get the numbers, but I can make those selections for what we call local analysis, and I can control the resolution of the results. When I hit recalculate here, what it's going to do is give me more appropriate results for those surfaces, so more accurate results. Okay, so thickness analysis, again, included in utilities. Now the last part of this is all about the reports. Now I mentioned reports for compare, geometry analysis, symmetry check. There's one for thickness analysis. There is also a report manager tool that will help you to manage all these reports. That is in here under the compare section. You'll find the report manager. This is where you can browse to a particular location. In this case, I was using and creating reports in this section. And this is where you can do things like managing how many reports, deleting, exporting, or viewing the individual reports. Now, the reports are all HTML based. There is quite a bit of information in them. I would recommend checking some of this out. But the last utility that I had today is the report manager to manage all of that. Now, I think the great thing about all these tools is that they're all included in the base package of SOLIDWORKS now. That's what I had for today. I want to thank everyone for attending another Lunch and Learn, and I hope you got something out of it.
Don't forget to check us out on YouTube, Twitter, Facebook, and our blog for more great content by clicking on the links in the description below.